There we go. Okay, awesome. So I know my talk title is a little bit provocative, as testing and prod is generally something that's sort of frowned upon in the industry, but I still think it's something that we should consider in different capacities. So we'll get into that in the course of the talk. Thank you for having me. My name is Ryan Emberling, and my talk is called Sensitivity, Precision, and When to Test and Prod. So we're going to start with a bit of background on the premise of the talk, then get into the fundamental thesis, which is about the relationship between the value that automated testing software can add to your organization and the architecture underlying your testing systems and its associated risks. Then we're going to make some comparisons between my use of Cypress at my job at the Assistments Foundation and in my open source card game side project. And then we'll sort of wrap things up with a demo that demonstrates the value that you can get out of testing in while sort of maintaining an awareness of the risks underlying the assumptions of your architecture. So a bit about me. As I said, my name is Ryan Emberling. I'm the Director of Engineering at the Assistments Foundation. I'm also the creator of Cuddle.cards, and I am a lifetime lover of math, philosophy, music, and games. As for Assistments, it is an edtech nonprofit with a relatively small engineering team that maintains a family of highly interrelated products where different kinds of users share data asynchronously. So for example, teachers will create homework assignments that students will then complete at a later time in a way that informs not only the teacher's report and insight into how the class is doing, but also district administrators using yet another application. So this is a peek into what the teacher experience looks like at Assistments. As for Cuddle, it is an open source, real-time PvP card game with a whole host of edge cases that sort of culminate out of the rule set. So here you can see the game itself. Cuddle is the oldest of the battle card games, so it's games like Magic and Hearthstone, but it's played with a standard deck of cards. And here you can see players are accumulating points, stealing each other's stuff, and blowing things up, and that kind of thing. So why are we here? Anybody who has written automated testing software has encountered the essential question, what should I test? And I'm here to suggest that prior to answering what you should test, you should consider why you're testing in the first place. And as you make the decisions of how you're going to architect your testing system, you're going to be continually facing compromises, areas where you'll find inherent trade-offs between some of the advantages and disadvantages of the choices that underpin your testing system. And you can use risk as a guiding principle for assessing those decisions in terms of what it is that your tests will tell you under a given architecture and what it is they won't tell you. So the fundamental idea is that thinking critically about the reasons that you have for testing and the risks that you are and are not willing to accept will help you to create a testing architecture which will deliver maximal value to your team. What you're going to get out of this talk is a framework for thinking about value-driven testing strategy, a lens for analyzing risk and architectural decision-making, and a look at testing in practice and how testing can add value to a given organization. So let's talk about value, architecture, and risks. When we talk about the value that testing can add, it's really about considering why is it that you're going to test in the first place, which is usually a matter of who's going to benefit and what are they going to get out of it. Often this is a matter of saving time and increasing the confidence that we have that our applications work, so it can benefit the users in that way and also members of our organization. But it's worth often getting nitty-gritty about who specifically is going to benefit in what particular ways by considering what it is that you would have to actually do if you were not going to use automated testing or if you were to test in a different way, because that's how you can really drill into what specific benefit you're going to get and use that to guide the decision-making of how you're going to approach your test. So That decision-making culminates in what I'm calling testing architecture, where the architecture consists of the style of test that you bring to bear. Are you using unit tests of individual functions, component tests that analyze sort of pieces of your application, integration tests, end-to-end tests, as well as the environment in which the tests are run? What physical machines are executing which software? What code is your actual application code versus your mocks? All of this sort of contextual infrastructure and the utilities that you build into your testing system in order to automate the parts of testing that are sort of the most onerous and slow. And each of these architectural decisions will come with risks. And so we're going to look at how to think about the identification and the evaluation of risks, thinking about what could go wrong and how bad it would be if various things went wrong, and using that to guide your thinking about ultimately what, if anything, you're going to do. So let's talk about risk. We're going to borrow some of the data science concepts of sensitivity and precision to think about the identification of risk. And then we're going to look at its dimensions as a method of analysis, of evaluating risks. These data science concepts are often computed quantitatively in data science, but we're going to be using them qualitatively to just think about categories of risk in order to kind of get the juices flowing to identify different kinds of things that could go wrong. So when I say sensitivity in a QA context, what I'm talking about is the probability that an application failure would cause a testing failure. If you consider the princess and the pea, this is the likelihood that if there really is a problem, a pea in the mattress, what is the probability that we're going to actually notice it? And reciprocally, precision is the likelihood that a test failure implies a legitimate application failure, as opposed to something flaky or spurious or particular to a quirk of your tests. So it's the likelihood that if we notice that something is amiss, that there is legitimately a problem. So we can use these lenses to identify risks, and then we can talk about the dimensions of risk in order to evaluate them, namely the severity, how bad is the problem if it were to happen, the probability, how likely do we expect this problem is to occur, and the detectability. If it does happen, what are the odds that we notice it in a way that will allow us to meaningfully mitigate the problem? So let's use this lens to look at testing at assistments. So we'll start as I'm recommending with the consideration of value. How is it that we can get value out of testing at assistments? Well, remember that we have these highly interrelated products. So for one thing, we need to ensure that each individual product functions correctly and delivers an excellent user experience. But additionally, we need to ensure that all of the products interact in the correct way. And this is often a point of complexity when it comes to testing assistments thoroughly. And because of this, we still rely in a significant fashion on manual testing for some of these cross-product interactions. And so reducing manual testing through automation is a key value driver, which we can use as sort of a guiding lens when it comes to identifying how to prioritize the automation of our testing process. We can literally measure it in person minutes per release cycle by looking at what manual testing is the most time consuming. So what are the actual applications that we're testing, and how are they sort of architected? Well, we've got different client applications, say one for teachers and one for students, where they're interacting by communicating with a server that has a family of interrelated APIs on it, talking to a database server that itself has multiple databases. And we use Redis for cache management to improve query performance. So each of these sort of constitutes one stack where you can interact with the various assistments applications. And we have a separation of our development, test, and production environments, where we sort of replicate this entire stack as a part of our software development and release cycle. So how do we actually approach testing at Assistments? Well, generally, Assistments highly utilizes end-to-end tests, where we legitimately boot up the entire stack and test the full thing. So let's think about the risks that are entailed with that setup. Well, we can start with sensitivity. What are the ways that our tests might fail to detect that something is wrong? Of course, the first is limitations in coverage. There are challenges when it comes to architecting the system and the tests in this environment where we have multiple applications that are all interrelated in various ways that can be complicated. And so the time that it takes to develop our tests means that our coverage is incomplete. And so those limitations in our coverage are an obvious way that we could miss something. But these are things that we largely know are not yet tested in an automated way, which helps us to think critically about them. And additionally, we have these three separate environments of development, test, and production, but there are some differences between them. In particular, the ways that we manage database migrations, for example. But there's always going to be differences. I mean, even something as simple as DNS, right, is configured differently in each of your environments. And so we've noticed that there are some differences that we generally want to make as close as possible, but that can cause us to miss problems where a deployment to test may not be fully reflective of what's going to go wrong in production. As for threats to precision, ways that tests could sort of fail spuriously, some of it has to do with when we run our tests. So we use code pipeline to deploy our code, and after a server boots up, we execute the tests through code pipeline. And this itself has some quirks where we've seen, for example, that particular database queries sometimes run more slowly in a way that can cause timeouts, like right after the deployment process, in a way that is problematic, but not really representative of user experience during sort of normal operating hours. So that's a threat to our precision, where tests are not fully representative. Additionally, there could be other environment-specific problems that are failures in development or tests that are not problems in prod. And if these cause test failures, this is a threat to our precision. So with these sort of broad strokes of risks identified, let's take a look at one in particular, the environment-specific configuration and differences between our environments and how this could cause, in particular, threats to sensitivity, failures in the application that might be missed during testing. At Assistments, this is something that we consider highly severe if it would happen. I mean, it could crash one or more of our applications if the problem is bad enough, or worse still, it could even potentially cause issues where misconfigurations at the database level cause the application to be up, but writing data in a corrupted fashion that causes problems to sort of accumulate over time. The probability is something that we've seen often enough that we've identified it as being a moderately probable outcome, which is worth mitigating. And the detectability, on the other hand, is relatively high. And this is detectability is a dimension where we want a high value. So it being detectable is a good thing. You can, there are a whole bunch of different ways that you can approach the sort of quantification of risk assessment, but a relatively straightforward one, if you've got low, medium, high, is to rank them 1 through 3 and take the product, which would put this at a 6. And then it's a part of your own sort of organization's prerogative to decide what makes sense for what is a risk worth mitigating. But at Assistments, we've decided ultimately that these various challenges and sort of threats to sensitivity as well as precision in our different environments make it worthwhile to test not only in development and in test, but in production as a part of our sort of deployment cycle. So in this case, I'm not advocating for doing all of your testing only in production, but rather considering what, if anything, is it worth checking when you deploy to production, in addition to whatever you've checked in test. A simple thing you could do, for example, is navigate to your site and confirm that it's still up. That's, in a sense, a test in production, and it's one you could consider automating. But at Assistments, we've opted even more rigorously to run a full suite of tests against production because the data that is generated is harmless in our use case, and this increases our confidence that we are mitigating the risks to sensitivity that come from environment-specific configuration issues. So what value do we get out of this? Well, ultimately, we're testing across all of our products because we're testing end to end. And this reduces the amount of manual testing that we need to do, because ultimately the manual testing protocols that we have, given these highly interrelated products, all have to do with working across products, having a teacher assign something and then completing as a student and then viewing reports as an administrator, for example. And in some areas where we haven't yet fully automated the testing flows, we're also able to automate sort of segments of manual testing by bootstrapping the manual testing with data seeding or sort of other ways that shortcut the amount of manual testing that's done. So even though our coverage is imperfect, the time that we do have, or the time that we save with automation, really cuts very directly into time that would otherwise be spent doing manual review by QA. Let's contrast this some with the Cuddle context. So because Cuddle is an open source project, one of the key value drivers is to streamline onboarding. We have a fair number of people that are coming in and making contributions sort of left and right, and we want to make it as easy as possible for a new person to come on and contribute to the project and run the tests. Additionally, we, of course, as everybody does, want to be able to detect regressions in CI. And because this is a PvP game focused around multiple users interacting in real time, the ability to facilitate development is enormously time-saving and valuable. We're going to take a look at this during the demo, but it's there are lots of edge cases that center around how multiple users interact. And so having a testing setup that automates development is enormously valuable. So the architecture of Cuddle is somewhat structurally similar, but simpler, because while we have multiple clients that are interacting in real time, it's all the same client code base and all one server. We have multiple players that are in a game talking to each other in real time with a server, which is using a database for persistence. And again, Redis, although in the case of Cuddle, that is for session management rather than sort of query optimization. But still, it's an analogous stack, but overall simpler because there's a singular code base, which makes it reduces many of the barriers to seeding data and generally to automated testing. So the approach that we've taken for testing Cuddle is to mock both Redis and the database, which of course comes with significant risks. In particular, our threats to sensitivity, of course, include database errors and Redis errors. I mean, we're literally mocking those services. So the API code is the same backend, but we're using mock libraries that are sort of built into the backend framework for Cuddle in order to effectively mock all of the database writes and the session store reads and writes. So any errors in sort of the versioning of those tools or in sort of the dependencies themselves could cause application failures that might not be picked up in testing. Additionally, we don't really test all of the visuals exhaustively for Cuddle. I mean, generally, we're making assertions about the presence of elements in the DOM or the lack thereof, and the existence of classes, but not of the particulars of any of the styles that are applied. So those are all areas that things could potentially go awry. As for precision, we could see issues in the mock libraries that potentially cause failures in the tests that are not necessarily problematic in a production environment, or in our testing utilities, any sort of quirks of the testing setup that is not fully representative of what actually happens in production could be a threat to our precision. So let's take a look at the database error side of risks. This is a broad family, really. There's a number of things that can go wrong at the database level, but in general, these kinds of problems can be highly severe when they happen. For example, I personally made the mistake when upgrading node versions of upgrading the mock dependency to the correct version, but failing to update the adapter in such a way that the tests passed in CI, where we're mocking the database, but then the deployment actually crashed because it didn't have the right version of the actual database adapter. But the likelihood of this happening is quite low because generally the dependencies for the mocks function well themselves. They're well vetted and well written software. And the kinds of version updates that we need to run, which sort of run the risk of these inconsistencies are not something that we're doing very frequently. And when it happens, it's something that's loud and clear because it generally crashes the entire application and is relatively easy to revert in a pinch while we sort of debug what actually happened. So this gives us a lower overall risk. And for the use case of Cuddle, this is one that's been deemed acceptable. This isn't to say that everybody has to accept this level of risk or this kind of thing. And it's potential that we might ultimately replace the mocks with a containerized instance of the database in Redis, for example. But this framework for thinking about the identification and evaluation of risks lets you own the assumptions and their associated risks that underlie your testing architecture, so that you can make these choices deliberately and rationally. So what value do we get out of testing Cuddle in this way? Well, for one, the mocks and the general setup is quite easy to get going. You can just clone the repository, npm install, and boot and run the tests. It's very straightforward, especially for new people, which is quite useful. It's also very effective for bootstrapping the application into edge cases. We're going to take a look at that during the demo. And we've got a setup for working with multi-user flows, which is a part of the core functionality of the application. And ultimately, we're able to vet contributions that come in through our CI system because we have relatively high degree of coverage, in part because the tests are so easy to write for this use case. So that's great. The mechanics of how we get this value is largely about our testing utilities. And there's a whole bunch that could be said about testing utilities, but broadly, it's really helpful to have tools for running setup of various situations, tools for programmatically interacting with your application in various common ways, and tools for making assertions about the state of the application. Let's take a look at that with a very brief demo, which first, we need to understand a particular bug that happened in Cuddle and how it ultimately can be solved in a way that's improved by testing software. So to understand the bug, we have to first understand that you can play cards in different ways in the game of Cuddle. One of them is called a one-off effect, where you scrap a card for a unique effect based on the card. And the effect of a 7 is you get to look at the top 2 cards of the deck and pick one of them to play. The effect of the Jack, which we could pick in this case, is to steal somebody else's point card. And this can cause a sort of unique and unfortunate situation for a player, because a Jack is the only card that can't be played all the time because it's dependent on having something to steal. So this can cause a situation, if you flip 2 Jacks, where the opponent doesn't have anything to steal, and oh no, so sad, you have to discard one of them instead of being able to play. And we have a dialogue to handle this situation, essentially. But we didn't realize in the initial implementation to consider the entirely possible edge case that the last card in the deck is a Jack. And similarly, you play a 7 in that situation and you can't play the card. And in this case, because of the bug that we're going to take a look at, the dialogue didn't pop up and the game was unplayable. While it took a while to hit this situation in production because it's relatively obscure, when it does happen, it's quite unfortunate. You literally can't play because the game is waiting for you to make a move and there's nothing legal for you to do. So with that, we can take a look at how to use Cypress to actually address this problem and to automate the sort of most tedious parts of it. Here, I've got the very beginnings of a test case for discarding the last card from the deck, and all I've got is to set the viewport. So the first thing that we'll do is set up a game as player 1. And here we can see Cypress run on the side. And every time I'm running my testing software, I'm saving significant time here. Here is a testing specific bug about the authentication of our under the hood socket that we can see. That's a hit to our precision. But basically, this is one of our setup utilities, and it saves us a significant amount of time because it drops us into a game as opposed to having to do this by hand. The next thing that we're going to want to do is put the game into a specific situation. This is another setup function. And here I'm going to load a game fixture that makes the second card of the deck, let's say the Jack of Hearts. And every time I save, it'll rerun the tests. And now it's the other player's turn, so we want to draw a card as an opponent. Here we're interacting on behalf of an unseen opponent. And then we can start interacting on behalf of the player by getting the 7 of clubs. So 7 for 7 and then 0 for clubs in the player's hand and clicking it. Notice when I do that, I'm going to get options for how to play my card. So I'm going to additionally slide out get data move choice equals, this bug happens when you play a one-off, and click it. And notice when I do that, the opponent is going to get this option to counter, because you can counter your opponent's moves in Cuddle. So I'm going to additionally use this effect to resolve the player's 7, which is going to bring it, make the effect happen, and this should trigger the bug. So now the 7 gets played, we resolve the one-off effect, and here we see the problem. So we can do the last thing in the spirit of test-driven development, which is the 7 double jacks dialog should be visible. And now we can fix the problem, which is in the game dialogues, where the function that decides whether we should open this essentially was checking that the second card was a jack, but we need to consider the additional case that it could have instead not been defined. Here's our spurious failure again. Not this dot second card. And what I want to stress here is that the setup of the very situation where the last card in the deck is a jack, and we are and we play a 7 and then it resolves and it can't be played, would have taken so long to get to without this testing software that our ability to just automate that situation is a key value driver. There we go. The jack appears, we can throw it away, and the bug is fixed. So with that, I want to bring us back to the fact that if you think about the value drivers underpinning where you can save time in your testing, that will let you make architectural decisions in sort of ownership of your risks, which lets you make deliberate trade-offs about your testing choices. So ultimately, what does this say about whether to test in prod? Of course, it depends. But if you think critically about what you're trying to get out of the system and take ownership over the risks underlying your architectural decisions, you can get the most value out of your automated tests. Thank you so much for your time and for listening to my talk. I'd like to thank the Cypress team for inviting me to speak with you, as well as my colleagues at Assistments and everyone who's helped me with Cuddle.cards.